So in multivariate analysis, we usually see the depth of insights that we have drawn till now, more interesting insights, and we can also explore the collinearity. There are a lot of insights in bivariant case or in univariate case where we are having some questions in our mind, and uh, uh, there can be a situation that we want to explore uh, some particular statement, some particular insight in more detail. Okay, let's say here any insight in bivariant. Let's say there is more chances to default highly skilled persons compared to other job categories. There can be a question that raise in your mind that is it it seems like how it is possible highly skilled person usually default compared to other category or more likely to default compared to other categories. Then in that type of cases, when you want to explore some statements, some insights more, um, you want to go in the detail of that, in the depth of that, you can use the multivariate, and you can go towards the multivariate analysis. In the multivariate, instead of just two variable, just one variable, we there are multiple variables like three variables, four variables, multiple variables involved during the analysis. Okay, so here I am just copying my data, and why I am copying my data here, I am changing the category risk. Okay, so risk was having the type int, so I am changing it as object. So if I will run this. Okay, so here continuous variables and categorical variables. We have three continuous variables we know, and other seven are categorical. And out of seven, there is one which is our target variable. Okay, so here first of all, the same pair plot that we have used in the by variant. Here I am also using hue is equal to risk, so that I can see either some particular category of risk like a 0 or 1 have uh, some significant, some clear relation with some numerical or continuous variables. So here you can see, although we know that continuous variables have no such a clear relation with or significant relation with each other, there is no such a collinearity in case of continuous variable. And when we use hue is equal to risk, there is red points are the showing the defaulters, and blue are showing a non-defaulters. And there is such a overlapping, though there is no clear, distinct uh, relation in our distinct, you can say the pattern in the that is describing that uh, defaulters are more likely to uh, have this range and non-defaulter have this range. That type of, there is no such a clear distinction. There are a lot of overlapping. So we can say that yeah, it is not giving us some interesting insight. Okay, now we will go towards the part. Let's say we have explored in bivariate analysis the people who are highly skilled are more likely to default compared to other categories, and we also have seen in the case of purpose the person who have the purpose of vacation or others or education, they are more likely to default compared to other purposes. Okay, so we can have we can the question can rise in our mind that is there some relation of job category, let's say a highly skilled category with some category of purpose. Okay, is there such a relation? Maybe that due to that relation, highly skilled people are more likely to default. Okay, or in other words, you can say there any collinearity between categorical independent variables. Uh, that's why we are having some relation of some categories relation with our target variable. Okay, so for that I am using here job versus purpose versus risk. Okay, so it's up to you. You can explore multiple combinations. There can be there can be also other type of combination, other type of questions that can raise in your mind that are not right now in my mind, and this also depend upon the project, what type of insights they want to know. Okay, so for that purposes we can go for the multivariate part. So here I am using categorical plot. Okay, so categorical plot, if I will show you here, it's very uh, you can say a high level categorical or high level function that gives you a lot of flexibility in it. Okay, the reason is that if I will zoom here. Okay, so here you can see in the categorical, when you will use cat plot, there are multiple categories that you can use, like by using that same function. If you will change the kind is equal to strip, you can use as a strip plot. If you will use kind is equal to swarm, you can use as a swarm plot. In this way, strip plot, swarm plot, box plot, while and box and point, bar, count plot, these eight plots you can plot by this cat function. Okay, cat plot function that we are going to use here. And here first of all I am using kind is equal to count. Okay, so you can plot multiple plots by using that function, and it also helps you to plot categorical, or you can say multivariate, or multiple variables in one go. Secondly, here you can also get from this categories that for the scatter plots, categorical scatter plots, we usually have strip or swarm plots. For the categorical distribution plots, we usually have box plot, island plot. Box and plot is some sort of like a box plot, in that there are multiple quantiles. It's similar to the box plot. When we have to use estimate plots, we want to estimate how, like estimate of mean, estimate of center tendency, that type of cases we usually use point plot, bar plot. And when we have categorical variable, then for the frequencies estimate or frequencies, we can use count plot. Okay, now here this cat plot, here I am passing my data. X on the x-axis purpose, rows will be job, and the color or hue will represent the risk, and kind is count. Here you can see these three variable that I am using here, all of are categorical variable. Okay, there is no continuous variable here. And when you will see, first of all, we were interested in the case of when job is equal to highly skilled, and we know that the people who are highly skilled more likely to default compared to other type or other job categories. Is there any some significant or some clear relation of highly skilled category with some category of purpose? But here when we will see the purposes categories, you can see in all the categories there are number of samples here. Okay, all have just except the domestic appliances and repairs, all the categories have some samples in it, which is representing that this highly skilled is not restricted to some particular categories. Let's say in the case of vacation or education, there are more chances to default. So if there will be just two bars against two categories, vacation and education, and there will be no bars against other categories of purpose, then we can say that highly skilled category has strong relation with the vocation and education category of purpose. But here is not that say that type of situation. Okay, but here we can draw some depth insights in that way, that you can see here that default default count is have more height compared to the non-default, um, you can say non-default counts. Okay, or bar. What it is actually representing, it is the number of samples belonging to the default category who has the job highly skilled and purpose vocations. Okay, this orange, the person who have who the person who have category not default, the number of persons who have category not default, job highly skilled, and purpose vocation. Okay, it's a three dimension or combination of three categories. each bar is representing here. In this way, you can also explore the other. Everywhere is showing that uh, like a defaulters are less in number compared to non-defaulters, and it's also in our insight, like in univariate we know that 70% of our observations belong into non-defaulter category, so it's not unusual here. Okay, so there is no such a interesting relation between the job and purpose, but there is a we have drawn some depth insight when the case of when there is job highly skilled, the vocation and purpose is vocation or education, there is more chances to default. Okay, so it can be we can say we have drawn some depth insight from here. Okay, so after this, you can see here we can draw cross tabulation, and I have told you in the case of cross tabulation in bivariate analysis we just using two variables, but here it's up to us. We can use we can get a data frame of cross tabulation uh, involving multiple variables. Like here I am passing index as a index list of series. Okay, two variables I am passing as index and one variable as a columns. Okay, I am creating a data frame, and here you can say this type of data frame in which uh, this is index one. Let's say this is index one, which has job highly skilled, skilled, and unskilled non-resident, and against each category there are purposes like highly skilled, business, which and in this case when the combination is highly skilled and purpose is business, there are 8 samples belonging to the non-default category and 7 samples belonging to the default category. Okay, and to see the percentages, I have just added two new columns on that data frame, and now I am here seeing the percentages of non-default persons or default persons. Okay, and here you again can see that in the case of highly skilled, the more percentages uh, are more percentage of default persons compared to the other categories. Here you can see there are 35, 32, 30, 42, 30, 22, 38, 0 when the job is skilled, and these all categories of purpose. But in the case of when job is highly skilled, there are a lot of percentages of default: 47, about 30, 50%, 43%, 23%, 56 approximately percent. And you can see here, and in the case of vocation, there is more percent chances of default. Okay, when there is job highly skilled and purpose is vacation, and there are 9 samples that are evident that are evidence of that percentage. 9 samples out of 9 samples, there are 56 samples belonging to the default category and 44 approximately samples belong to the not default category. Okay, in this way we can draw insights, and we can also see the our uh, frequencies in terms of some contingency table, or you can say in terms of some counts. Okay, we can also see the numbers, or how many numbers involved to some particular combination with some particular category. Here most chances to default person with highly skilled and purpose vacation and others. We have drawn some depth insight from here. Okay, okay, so now there can be a situation that you can have question in mind: is there some particular relation between a particular category of saving account with the particular category of checking account? Let's say saving account have four categories: little, moderate, quite rich, and rich, and checking account have three categories: little, moderate, rich. Okay, so these both have type of similar type of categories. Is there some particular strong relation between some categories or some specific categories of both columns? We can explore that. Like here I am using cross tab, and I am visualizing contingency table against saving count and checking count. Saving counts are on the along the indexes, and checking count along the columns. And here again, there is no such a strong relation between some two particular categories. Okay, let's say what I want, I will say a strong relation. What type of combination? Let's say if there will be uh, 0 at this position, 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 and there will be number of points belonging to that corner. Okay, then I can say that, oh, in the case of saving count, when the saving count people have reached saving count, there must be a chance that people will have reached checking count. Okay, that type of strong collinearity I want to see here. Is there such type of collinearity? But there is not so such type of collinearity, and it's also good in our case, because keep in mind collinearity in case of the models that have equations like linear regression or logistic regression. Collinearity is not a good, you can say, it's not a good for the case of linear regression and for the case of logistic regression also. Okay, by the collinearity, it can bias our model. Okay, some, let's say one column has some strong relation with the target column, oh, and another column also have strong relation with the target column, and both columns also have strong relation with each other. It can cause, it is also the collinearity, and it can also cause the biasness in our model. It can also lead to unfair training of our model. Okay, so we are not happy with the collinearity, but we want to explore that if there is some such type of collinearity in our data set. Regarding the continuous variables, we can have we have seen by using a correlation matrix, we have seen by using pair plot. But in the case of uh, categorical variables, we have to see some contingency tables, some frequency tables, like here the case of cross tabulation. Okay, but here saving count and checking out have no such a strong relation between each other regarding any particular category. Okay, so now if we will plot saving count versus checking count versus risk by using the count plot. Here I am using the count plot as again these three categories are categorical, and here hue color is risk, and along the columns checking account, like this is checking out little, checking out moderate, and checking out rich. Three columns we have according to the category of checking count. And along the x-axis we will have saving counts. This is little, quite rich, rich, moderate. Again little, quite rich, rich, moderate. Against each checking count, there is four categories of saving counts, and again each category or each combination, like when the checking count little and saving count little, there are two bars we have. Okay, this blue bar is showing that the number of persons or not default persons with saving account little and checking account little. Okay, here you can say person of default, or the persons who are at risk. This orange bar is showing who are at risk and having checking count little and saving count little. Okay, now by visualizing this type of count plot, you can see here, like in the case of when checking out rich, there is a less number of defaultees here. Okay, you can see in the case of liter, there is also a very less number of less percentage of default compared to the not default. And in the case of quite rich, rich, moderate, there is no any sample that have um, that belong to the one category that are that is at risk. Okay, so if we want to see some in terms of numbers, frequencies, uh, in terms of figures, then we can use cross tabulation. And here I am passing two columns as indexes, checking count and saving count, and on the columns I have risk. Okay, when I will see the contingency or frequency table, here you can see in the case of checking account little, and in the case of saving account, uh, here we were having this saving account, checking account rich, and saving account. checking or rich, and saving count you can see here in the case of moderate, in the case of quite rich, in the case of rich, there are 5 plus 4 plus 3, 12 samples here belonging to these three combinations, and out of 12 there are just 2 samples that are belonging to the default category. Hence we can say here that least chances to default person having rich checking count and saving count, any saving account except deleted. Okay, so this can also be a depth insight from the uh, this analysis, this multivariate analysis. Okay, another least chances to default person having little checking count, having little, here you can see in the form of percentages. And yeah, this can be a, when there is person having little checking count and saving count quite rich or rich saving count, there are 14 samples, and out of 14 samples just 2 samples that are uh, belonging to default category. So this can also be a inside that person who have little checking count and rich or quite rich saving count, there is least chances to default. So most chances to default here, persons having little checking count and moderate saving account compared to the persons who have uh, persons with other saving accounts. Yes, here you can see like here 58 and 41% chances to default, but other categories have less percentages. Okay, so in this way you can also draw the depth insights by using multivariant, and also you can explore in terms of collinearity is any or a clear relation between some particular categories, some specific categories. Okay, so here housing, uh, there again the question was, is there some particular relation in the category of housing with some saving count or checking count? Okay, as we know that from univariate analysis, 71% of our samples have own house, 18% have rented house, and 11% have free housing. So most chances to default persons who have rent or free housing compared to others. These are insights that we were having from the univariate and bivariate analysis. So here we will see the relation between the saving account and housing. And you can see from here, this is saving account on this axis and housing on these along the columns. And there is again feels like a fair there is fair distribution of the data points, like in the case of we know there are more points belonging to little or moderate category, that's why there are more points in all the categories of little and moderate. And again this is spread is not such a uh, giving some insight regarding the collinearity. Here again, own has the person 71% have own houses, and again they are greater in numbers. In the case of checking versus housing, again there is no such a relation between some particular categories. Okay, now we have 4 variables and are categorical variables. So we can also plot 4 variables by using cat plot function, and here we will see. Okay, so on the x-axis saving count, along the columns checking count, on the along the rows housing, and color will represent the risk. Okay, so it will be again the count plot, and let's say from here I will describe you. This orange bar is representing the number of people, number of persons who are at risk. Okay, who have risk is equal to 1 and having housing, uh, rent, checking count little, and saving count little. Okay, there are four combination of 4 variables here. Okay, and in this way you can explore the bars, like here in the case of saving count, uh, in the case of housing, rent, checking count little, there are again less number of samples belonging to the uh, category default category here. Okay, and in terms of Here again you can see there are a lot of bars that are have no height. It means there is no sample belonging to that category. Like in that case also you can see. Okay, and in terms of numbers, when you will use a cross tabulation, and here I am using three variables along the indexes and just one column along the one variable which is risk as a column and three as indexes, and these are the combinations. Okay, and here if we want to explore this one, when the housing is equal to free and checking count is equal to reach. Housing free, checking count rich, and in that case there are little, moderate, and quite rich, and rich have just have no sample belonging to that combination free and rich. And here you can see there are again less number of samples belonging to these categories, so that's why there are such type of zero heights also here. Okay, housing free, checking count rich, housing free, checking count rich, and little and moderate and quite rich. They are very low heights. Okay, just one here. We cannot also clearly see from here the bars. Okay, okay, there are also a lot of zeros here, lot of zeros here. And if we want to see some insight from here, this can be from this, that when the checking count little and any saving account or housing is equal to rent, then there is less chances of default. This can be a insight. So least chances to default samples having housing is equal to rent, checking count little. Yes, and here you can see and saving count not equal to little, then there are five samples to belong in that category. When the rent plus little plus moderate, rent little plus quite rich, rent little plus rich. There are five samples, and all five samples belong to that combination are all not belong to not default category. Okay, so this can be some depth inside. Okay, and if we will see the zeros, there are a lot of zeros, and if we will see by using some conditions on the data frame, we want to see here the zeros, and there are not of such a significant you can say insight from this zero, because there is just one sample that belonging to this combination free little quite rich, and this sample belong to the default category, so we cannot say that uh, uh, the person who have housing free checking count little and saving count quite rich more chances to default, we cannot say here because there is a very little evidence we have here, just one sample is proving this. Okay, again you can see there are very less number of samples proving that. There are in just in that case when the housing is on checking out little and saving count rich, there are four samples and all four samples belong to the belong to not default category. So we can say that this can be inside, but in all other cases there is a less number of the samples belonging to that combinations. Although there are a lot of zeros, but very few samples belong to the combinations. Okay, so there are two insights that we can say we have drawn from this four variable uh, multivariate analysis in which four variables were involved. In the same way, we can also like here age versus risk versus job. Let's say it can be in your mind that the person who are highly skilled can be due to and they we have insights here, the person who are younger more likely to default in the case of age, and in the case of job the persons who have category highly skilled more likely to default. And if we want to see the relation between age and job, is there some particular relation, like a highly skilled person have younger ages or are of younger age, is there any type of relation like this? So we will use the cat plot, and here we have one continuous variable involved here, so that's why instead of count plot I am using here the bar plot. Okay, and you can see here again, younger customers more likely to default in each case. In the case of highly skilled, almost both have equal type of ages, but we cannot say there is no such a significant relation here regarding the age versus job. Okay, if highly skilled will have this orange bar will have very low height compared to below bar, then we can say that yeah, it seems like highly skilled persons more are younger as compared to other persons belonging to other categories of job, but here is not that type of case. So though no interesting insight here. And if we will plot housing also, if housing is also involved in this combination of three variables, then we can see here some interesting insight, like the person who have housing free and have high skilled job category are elder compared to the defaulters are elder compared to the non-defaulter. Usually we are having in bivariant overall that youngers more likely to default, but here in that particular case, uh, elders can are more likely to default. Okay, so in the case of purpose versus risk versus age, we know in the case of purpose, when vacation or education, the person have taken credit for that purpose, more likely to default, and in the case of age, we know younger persons more likely to default. In that case, if we will see the relation between purpose and age, okay, is there some particular like purpose? I want to see such type of relation here, like in the case of vocation and education, the person should have lower ages compared to the other categories. That type of relation I am expecting here. Okay, so but here it is again the spread is unbiased here. Here you can see the ages of vacation and others are elder compared to other categories. Okay, there is no such a relation that I was expecting. So we can say that again purpose and age has no such a significant relation or no such a clear collinearity. Okay, when we will see in the terms of risk, and here there can be a insight that when the purpose is business, domestic appliances repairs, then the persons are more likely, the defaulters are not younger than the non-defaulters. Okay, so in that type of case, overall defaulters are mostly younger than non-defaulters, but when the purpose or is business or domestic appliances, then defaulters are mostly elder than the non-defaulters. Okay, so in the case of purpose versus risk versus duration, we can here see the is any relation between some particular categories of purpose with duration, because we know high duration person who have high durations more likely to default compared to the persons who have low durations. And in the case of purpose, we know that persons who have vocation or education purpose are more likely to default. Is there any relation between them? So here we can see in the case of vocation and business, yes, here we can see that in the case of vocation and business, there is high durations, and in the case of vocation, there is a high duration compared to other categories. When we have plotted a cat plot between purpose and duration, and kind is point here. Okay, point is it's used for the estimate plot. Okay, and here you can see vocation have high duration. So high duration leads to more the person have high duration more likely to default, person have vacation more likely to default. And there is also relation between the this category to the duration, that vacation category have high durations. Okay, high duration. So there can be we can say that this can be a reason that the vocation, the person who have vocation, purpose vocation or business have high durations, so that's why he or she are more likely to default. Okay, so this can be a reason. So here there is some sort of collinearity exists in these two variables. Okay, so if we will see in terms of risk, default and non default, here there is no such a uh, uh, you can say odd behavior of vars. Each var is representing here a high duration, more likely to default compared to the low duration. Okay, but here you have seen that we have find out some insight regarding that vocation. The person who have vocation more likely to default due to the reason because he has high duration of credited of amount we usually credit. So here credit amount versus risk versus checking count. Now we can see is any relation between credit amount and checking account. Okay, credit amount, high credit amount leads to the person who default persons mostly have high credit amounts compared to the not default persons. Okay, and in the case of checking count, persons with little checking count compared to others are more likely to default. And if we will see here, but his is this little should be high. It's also high, and here we can say there is again some sort of because little and moderate both have high credit amounts compared to rich, and rich category have less number of when the check account rich there is less chances to default, and also rich have low credit amount. So there can be we can say that checking count and credit amount also have some sort of relation with uh, between them. Okay. Okay. So here when you will plot in terms of defaulties, here you can see in that particular case of when the checking count reach uh, their defaultees have low credit amounts compared to the non-default persons. Okay, so overall we know that credit amount in the bivariant we have overall analysis that higher credit amount customers more likely to default, but in the case when checking count is rich, then low credit amount persons more likely to default. Now, credit amount versus risk versus saving count. Now we can see credit amount versus saving count, and then we will see the risk. And in the case of saving count, again, persons who have little or moderate saving counts more likely to default. And here you can see in the case of little or moderate, both have high credit amounts compared to the quite rich and rich. Okay, so we can say that these category again, this variable saving count has a relation with the credit amount. So we can say that the persons who have little or moderate saving count, you can see in both ways. The persons who have little or moderate saving count more likely to default because they have high credit amounts. Or in other words, you can say the persons who have high credit amounts are most chances that they have saving count little or moderate. That's why they are more likely to default. Okay, you can say in both ways. Now, if you will see in terms of hue, in terms of risk, there is no such a odd behavior of bars here. Each bar is showing that high credit amount customer more likely to default. Okay, and here in terms of if you want to see in terms of box plot as along the y-axis there is a continuous variable. If you want to see in terms of box plot, you can see the variation of data points also. Okay, so overall insights in case of when we have univariate analysis tells more about the spread of the data points in variable, frequency of data points, central tendency, dispersion. This type of analysis we can get from the univariate analysis. And in the case of bivariate analysis, we usually have some overall insights, okay, some on insights that proves majority of the data points, majority of the cases, okay. But when we go towards the multivariate analysis, then we can also get the depth insights, okay. And I have collected all the insights and in here, so that we can do analysis on that. We can recommend to our we can tell in terms of story to our uh, uh, banks team. We can give them recommendations. Let's say any of let's say from here we know this class distribution, 70% observations are belong to not default category and 30% belong to the default category. It's drawn from the univariate analysis. Okay, frequencies of risk column. Here the second para here showing distribution of age is right skewed and mean 35, median 33 is again from univariate. Uh, Drawn from the univariate analysis, more chances to default younger customers compared to the elder customers. This is drawn from the bivariate, and defaulters who have housing, free, job, highly skilled are elder than the non-defaulter. Okay, so it is against the generalization. This bivariate case is giving a generalized insight, but it is giving some specific insight that in the case of when housing is free, job highly skilled, then there is general insight usually not hold, because here defaulters are mostly elder than the non-defaulters. If purpose is business or domestic appliances, then defaulters are mostly elder than the non-defaulters. Okay, so these two some specific insights in some specific conditions in or in case of some specific combination of categories, these insights are hold, and these are saying that in that case is most likely elder customers to default. Okay, so here univariate analysis inside bivariate analysis and multivariate analysis, all these sites are compiled and in the form of here bullet points. Okay, like here in the case of checking count, you can see 94% customers little or moderate checking count, and 6% customers we have that have rich checking count. Okay, now persons with little checking count compared to moderate or rich checking count more likely to default. Okay, now least chances to default, person having little checking count and rich saving count. Okay, here is not a comparison with some like in the above. Here it's a comparison with some other categories, but here is not comparison. It means that more than 50% chances to default when the person have little checking count and rich or quite rich saving account. Here persons having little checking count, uh, saving count and own the house. There are total four samples in the dataset that have this and have risk zero. So again, least chances to default in that case. Okay, so here you can see that these are the depth insights that we have drawn from the multivariate analysis. Okay, so all of that overall insights are here. Now you got an idea about we have discussed in more detail regarding the EDA when the target variable is categorical, how we can carry out the process, univariate analysis, then the bivariate analysis, then the multivariate analysis. We can draw a lot of insights from our data, what our data is saying, what type of behavior in our data set, what type of dispersion in our data set, what type of spread of data points of our data set. We can draw all type of insights. Then after EDA, we will go towards the part of model building in the next session. So till now, you got an idea. We have done the data analysis part also, and we also have understanding of the data of our data. Let's say there in our case there is not a no pre-processing need, but if we will need, we will do in the case of model building, where we need according to our requirement of the models. Okay, but overall, here again this concept I have told you like collinearity. In the case of collinearity, I told you collinearity is not such a good when we have logistic regression or linear regression. Okay, our equation have some assumptions that there is no collinearity in our data set. Okay, the assumptions for our models. Okay, so uh, like here, it's not a so old in our case. There is not a, such a strong collinearities. There are some collinears between some categories. This can be used as insights, reason for the insights, reason for the statements that we have drawn from the insights. But it's just a you can say it's a practice case study. So in the real time project there can be a chance that we will drop one of the column which have very strong collinearities. Okay, we can use one column instead of the multiple columns, so instead of two columns or three columns if they have some strong relations with each other. Okay, I am talking about independent variables, but here we already have just nine independent variables, so we will not drop that independent variables for now. Okay, so in the case of model building, in the next session we will start model building, and hopefully I hope you got enough from the EDA part that we have discussed here. So you can explore, you can see multiple combinations by yourself, you can explore some other type of plots, other type of visualizations, you can play with that you can play with that plots. Okay, so for now, thank you.